The taller and higher a building gets, the more susceptible it is to high wind forces. As structural engineers, we don't want our buildings to be unsafe under earthquake forces, and we also don't want our buildings to sway too much under strong wind forces. So, in order to improve the safety and the serviceability of super tall buildings under strong wind forces, we use what we call aerodynamic optimization to optimize the shape of buildings. This aerodynamic optimization is considered to be the most effective approach for optimizing tall buildings subjected to strong wind forces. But how does this work? Let's try to understand aerodynamics. What is aerodynamic? Aerodynamics is basically the study of air in motion and how it interacts with solid objects around it. There are some modifications that are used to improve the aerodynamic response of structures. Here are some of the modifications. We have tapering shape, which will look like this. As you can see, the cross section of the structure has been tapered. As you move from the bottom to the top of the structure, the cross section reduces. We have twisting shape, which will look like this. We also have set backing. Then the addition of openings through the building. How can we actually explain this? Due to these different aerodynamic modifications of the building shape, the response of wind motion can be reduced when compared to the response of wind motion on normal building shape, which will look like this. The shape of the building plays an important role in mitigating the effect of wind loading on tall structures. Square or rectangular shapes are very common for buildings, and this type of buildings experience relatively strong voltage shedding forces. However, many researchers recently found that if the corners can be softened through chamfering, rounding, recession, or stepping them inward, the excitation forces can be substantially reduced. For example, if you take a look at Taipei 101, you will see that the corners were stepped in order to actually reduce the across wind response and drag. This resulted in a 25% reduction in base movement. So the different aerodynamic form reduce the along wind response and across wind vibration caused by what we know as voltage shedding. By confusing the wind, they disrupt the voltage shedding and boundary layer around the building. Even though these irregular shapes can be a problem for structural engineers when developing the structure of a building, they can also be useful when reducing the wind load on tall buildings. For example, if you take a look at the Shanghai World Financial Center and the Kingdom Center in Riyadh, you will see a large opening at the top of the building combined with a tapered form. Due to the nature of this aerodynamic strategy, wind forces can be mitigated on super tall structures while also looking architecturally pleasing. What do you think of this aerodynamic modification concept? Let us know in the comment section below. Before you leave, don't hesitate to hit the like button and subscribe to the channel tutorial for more construction videos like this. With that being said, you all have a pleasant and wonderful day. God bless you all.